Hello everyone. Today we are here to discuss about page replacement algorithms. These page replacement algorithms are used in the concept of virtual memory. So actually in the system we have two memories. One is virtual memory and another one is main memory. So whenever we want to execute any particular page which is presented in the virtual memory has to be transferred to the main memory for its execution. So the virtual memory is divided into pages and the main memory is divided into frames. Each and every frame from the virtual memory is to be transferred to the frames of main memory for its execution. And in general we have more number of pages when compared to the more number of frames. So if all the frames are filled with one set of pages, we have to select one particular frame if we want to execute a new page. So then these page replacement algorithms can be used to select one of the frame for page replacement, and whenever the page is not presented in the main memory, that condition is referred as page false. And these page replacement algorithms are used from the frame selection in which the page has to be replaced, and we have to select one page replacement algorithm such that which gives less number of page faults. And we have so many number of page replacement algorithms are available. So one is first in first out, least recently used, optimal page replacement, least frequently used page replacement algorithm, most frequently used page replacement algorithm. And here in this lecture we are discussing about these two, that is FIFO and LRU page replacement algorithms. So first we will discuss about first in first out page replacement algorithm. In this first in first out page replacement algorithm, we are replacing the page which has been presented in the main memory for a longer period of time. So that means the oldest page is chosen for the page replacement. So to explain this FIFO page replacement algorithm, we are considering one reference page strings, and all these numbers refers to the page numbers, and we are assuming that our main memory contains 3 frames. So initially the 3 frames are free, and when we had received the page reference string as 7, it can be considered as one page fault and it can be placed in first frame. Similarly, the second page reference, that is 0, can be placed in the second frame and even it is also considered as one page fault. And the third page reference string 1, it is not there in the frame, so it can be considered as one page fault and it can be placed in the third frame. So for the from this point we have to apply the concept of this first in first out page replacement algorithm. So if you go for the next page reference string, that is 2, it is not there in all these 3 frames. So we have to select one frame for replacement. So as per the FIFO concept, the oldest page has to be replaced. So within 701, the oldest page is 7. So it can be replaced with our new page, that is 2. And the next reference string is 0. 0 is already presented within the main memory, so it cannot be considered as page fault. And the next page reference string is 3. And within these 3 frames the 3 is not presented, and within this 201 the oldest page is 0, it can be replaced with 3. So similarly we can move on to the next page reference strings and we have to find out how many number of page faults are there to process all these page reference strings. And in this example we had received 11 page faults out of this 14 page references. Next, we will discuss about the next page replacement algorithm, that is least recently used page replacement algorithm. And in this least recently used page replacement algorithm, we are replacing the frame which contains the least recently used page. And here always we have to take the reference of this page reference string from the left hand side onwards. Suppose if we consider this as our page reference string and we have 3 frames, so then anyway the first one can be considered as the page fault and it can be stored in the 0th frame. Similarly, the same thing can be done for the 0 reference string and the first reference string. And coming to the 2, so now we have to go through that which page has to be replaced. So since we are following least recently used, within the 701, the 7th page is considered as the least recently used page. So it has to be replaced with this 2. So next 0, there is no page fault. And coming to the 3, we have 3 frames in 3 pages in the 3 frames, that is 201, and here the least recent page is 1. It can be replaced with 3. So similarly, we can find out the page faults as well as we can complete all these page reference strings. So in the next video, we'll discuss about some more page replacement algorithms. Thank you for listening.